Hi, my name is Shazin Izwan bin Sulaimi, student ID 250599496. I'm from Group 7 and I'll be presenting on how to classify a predictive machine maintenance dataset. So this is the table of contents. We have team members, introduction, ID tree selection and justification, how ID tree works, reflection, and also a summary. So the team members, my team consists of 3 people, which is Asan Hanif, me, myself, Shazin Izwan, and Ansab Noor. So for the introduction, predictive machine maintenance. So one important use of artificial intelligence and machine learning in manufacturing firms is predictive machine maintenance. It focuses on predictive maintenance, which aims at forecasting when a particular asset is going to fail or would require maintenance so as to avoid any downtime, reduce maintenance costs while also ensuring efficiency in operations all through. Here, the target problem can be articulated as a binary classification exercise. In our case, we are concerned with finding out if a given machine or equipment will break down in a certain duration of time, class 0, and state the cause of failure, or will it continue operating fine as expected, class 1. This problem may be solved using decision trees.
Hi, my name is Ansab, and I'll be presenting how the ID3 selection and justification. Um, the AI technique we used was the decision tree matrix in order to predict data. We came up with this method when we were searching for datasets to use, as we struggled to find datasets for quite a while in order to analyze and predict data. But when we were searching on Kaggle, we finally found and stuck on a dataset that we were able to predict data on, and thus we picked decision tree matrix. The dataset focuses on machine predictive learning.
Okay, let's move on to the next part, which is how ID3 decision tree helps solve the problem. To make a decision tree, we need to first find the root state. So it will go to all of the points randomly and use entropy to determine the best root state. So what is entropy? Entropy is the uncertainty in the dataset, and this is the formula. Entropy equals to negative p log 2p, and it's the sum of it. So p is the probability. So it will calculate the points and determine which is the lowest, because the higher entropy, the higher the uncertainty. Next is the gain index. It is just the probability of misclassifying a randomly chosen element. And this is the formula 1 minus sum of probability times squared. Next up is the information gain, which is just the decrease in entropy. So information gain formula is info gain equals to entropy before minus entropy after. So the higher information gain, the better it is for the decision tree, as the decrease in entropy is higher. Okay, so after we get all of this, we'll just recursively loop it and until it will gain zero entropy at the end. Okay, that is all from me.
For the reflection and summary, in conclusion, this project allowed us to be immersed in the realm of predictive maintenance, applying the powerful ID tree decision tree algorithm. It was a journey of informed decision making, effective technical choices, and self directed learning. We hope that sharing this reflection inspires you, the viewers, on your own path of discovery and learning. Thank you for joining us on this journey.
Moving to Kaggle, here I'm able to show you the dataset here, machine predictive maintenance classification. Um, Explaining the dataset real quick, where I'm able to show you the unique attributes that are involved: UID, product ID, air temperature represented as K, process temperature represented as K, rotational speed, torque, and tool wear. Machine. There's also machine failure, which is categorized within two targets: target and failure type. Scrolling down, this is a quick overview of how the dataset would look like in its graphical form, and how the dataset would look inside Google Colab would be just like this. This is the Google Colab of how we solve the target problem, and we import the dataset just into here.
Okay, let's move on to the next part of the code, which is defining the node class. So in the node class, we just use it to construct the decision node and the leaf node. Moving on to the ID3 decision tree class, here we make the decision tree itself. To make it, we first initialize the root of the tree and make a stopping conditions of min split and max tree depth. So we first need to define the functions of the tree, which is split, information gain, entropy, and Gini. So in split, we just split the tree from left to right. In information gain, we calculate information gain using entropy or Gini. So entropy is just the uncertainty of a tree that I explained before. So we use the formula that we have and make it into code here. Same as in Gini, we use the formula that we have and make it into a code. So next up, I used the get split, get best split, build tree, and calculate leaf from the same website as before. In get best split, it's just to get the best split of the current decision node. So first we make a store to store the best split, then loop over all of the features, and then loop all over the features values currently. And then we retrieve the current tree split using the left and right split, and then check if the leaf node are null or not. So then we retrieve the information gain using the information gain function, and then lastly we update the split, the best split, if the current information gain is higher than the max information gain, and then we return the best split. Next up is the build tree. Here is where the building happened. So we split the tree until it reaches the stopping conditions, and then we find the best split for the nodes and check if information gain is positive or not. Then go to the left subtree and then the right subtree, and we return the decision node. After we've done that, we compute the current leaf node and return what we have from the current leaf node. And then we calculate the leaf value. This is to determine the value for each leaf node on the majority class. And lastly, I made this code to train our building tree so that it can predict later. I will show you the code for prediction later. So below are the functions to visualize the tree, which is print tree and visualize tree. This print tree I've got from the same website, but this is just to print the tree in text. While this one, visualize tree, it will print the tree in an image using digraph. Okay, so next we go to the functions that makes the prediction. I took the codes of function predict and make prediction to do the prediction later. While for the function predict input, I made the code so that users can input a value to the attributes so that it can make a prediction of the failure types. Okay, moving on, we load the dataset and split it into training and testing set. So here is the code to do that. For this code, it will take the last column as a target, and for this code, it will also take the last column and then reshape it from 1 dimension to 2 dimension, similar to a column. And then we make the split using train test split. We use test size 0.2 as we want to use 20% of the whole dataset, and then we just make it a random state so it shuffles. So next up, to make a decision of which hyperparameters to be used for the min split and the max tree depth for the best efficiency, I made this code to evaluate the accuracy of each min split values and max tree depth values. So here it will train the tree to make the decision for the dataset, and then it will return the accuracy. So I made the values 2, 5, 10, 15, 20, and the values for max tree depth none, 5, 10, 15, and 20. And then we make a mesh grid, which is just this one. And then we make an accuracy array. So this is the graph that we got from the values that we used. And as you can see, the best one to use is mean sample split 5 and max depth 5. Why? Because it is the lowest value that gives us the best accuracy. So we then train the decision tree using the values that we got above, and then we print out the tree. And then we make the prediction and use the prediction to make an accuracy score. And we got the same values that we got from the graph, which is 0.994, as you can see here. Okay, that is all from me. Thank you.
So to visualize the decision tree, including all the calculations. Okay, first of all, we calculate the entropy score and the gene impurity. Okay, the entropy score measures the randomness or impurity in the data. On the other hand, the gene impurity measures the same thing, but it is in an alternative way to do it. Both of these measures are used in building a decision tree. Next, visualize the decision tree. This step uses the graph face library to create a visual representation of the decision tree. The dot variable over here holds the graph, which is then rendered as an PNG image. The image is labeled with the entropy score and also the gene impurity. And then we just display the decision tree image using the IPython display function. Okay. And as you can see, if you run it, we will have ourselves a decision tree. Here, this is a full decision tree. And that's the end of the decision tree. Moving on, the next part of the code is to demonstrate the prediction of a failure type in a machine using a trained decision tree classifier. So the input data dictionary represents a single data point with attribute values. The attribute includes the air temperature, process temperature, rotational speed, torque, tool wear, and also target. In a real world scenario, you would, I would say, replace these values with the actual attribute values of the data point you want to predict. The predicted failure type. So the predicted failure type variable is obtained by calling the predict input method of the trained classifier object. This method takes the input data dictionary as input and returns the predicted failure type. And finally, the code prints the predicted failure type. And as you can see over here, the output was a power failure. And for the final part of the code is for a real value. We will be inputting real value into it. Okay. So first, an empty dictionary called input data is initialized to store the input data. Next, the code prompts the user to enter values for each attribute for the air temperature, process temperature, rotational speed, torque, tool wear, and also target. And these values are stored in the input data dictionary. And then, to prepare the input data for the prediction, the code converts the input data dictionary into a 2D array here, into a 2D numpy array called input data array, as you can see over here. And then finally, the code uses the trained decision tree classifier here to make a prediction. The prediction is made by calling the predict input method here on the classifier and passing the input data array as an argument. And finally, the code prints the predicted failure type. So when we enter the value for all the attributes, for example, the air temperature, the process temperature, rational rotational speed, torque, tool wear, it will show the output whether it failed or not. And as for this case, it failed. And the predicted failure type is a power failure. That's all from me. Thank you.